Okay, so this is going to be the start of Set Theory 2. I've been meaning to make this video series for a long time, but I've been very, very busy, so I have not yet been able to do it. But this is going to run parallel to, I'm going to do videos on this, and I'm going to do some on physics pretty soon, and I'm going to also do my organic chemistry one, and fluid mechanics I also plan on making. That kind of, I may, I think for the physics one, I'm going to go over some basic, topics, and then go more in depth fluid mechanics for that particular video series. But I digress. So, what exactly is set theory 2 going to be on? Well, a brief synopsis. We're going to be talking about infinite unions, infinite intersections, unions and intersection of n sets, some formal logic. Definitely, obviously, a lot about set theory. We're going to be talking about naive set theory, axioms of choice, Zermelo-Frankel set theory, and we may even dive into some fuzzy theory if I feel like doing some videos on that. We're also going to revisit the continuum hypothesis a little later. I've done a pretty good overview of it in my set theory 1, but I'm going to revisit it and talk about Cantor's diagonal argument a little bit and a few other ways to approach the continuum hypothesis. And we're going to talk about Turing's halting problem a little more. I briefly mentioned it in my theory of computation, but we're going to take more mathematical approach to it in this video series. And finally, we're talking about topology. For those who don't know, what topology is basically a study of spaces, like closed spaces, foldings, things of that nature. Not all of that detailed topology, basic topology, such as family of subsets, how to classify topological spaces, some properties of some, and then maybe even a little bit of rings. That comes later. But so this is a brief introduction. We're just going to be talking about more advanced set theory concepts, Zermelo-Frankel, Gödel, a little bit about Alan Turing and the halting problem. Some mathematical logic has to be thrown in there, and ultimately probably do about 5 or 6 videos on introductory topology, and maybe later I might do some more on more advanced topology. After I read up again, I need to read up more on the more advanced stuff, but I got the basic gist of it, some definitions and understanding, but I've not studied the advanced spaces as of yet. But that's for later attractions. Okay, so again, this is the intro video. See you guys later.